Welcome back to our Science Online Learning. This is still your teacher, Teacher Heidi. Our subject is Basic Science, Matheum 3, with the code of SC23102. How are you feeling today? I hope everyone is doing well. So for today, we are going to study all about electrical energy. But can you tell me what did we discuss last time? Very good. So the objectives of our lesson are the following. Define electrical energy. Compute for electrical power of appliances. Compute for electricity bill. And recognize the need for safety in using electrical appliances at home and in school. Now in your book, you could see this one. When we say electrical energy, this is the energy that is generated when we use our appliances. Electrical appliances vary in types and sizes and consume different amounts of electrical energy. The information labeled on the appliances or in user manuals specifies how much energy the appliances consume. Okay, so you could see here an example, which is the bulb that we use. Most of us here use this one in our homes and in school. So every information there has something to do with the electrical energy of these appliances. Did you understand? And here, you're going also to get the electric power generated when using these appliances. So when you say electric power, it is the rate per unit time at which energy is transferred by a circuit. So the source of energy, as what you all know, is what we call the potential difference. Now the potential difference delivers power, while loads, such as light bulbs, absorb the power and then later on they convert it to light or heat, or actually both. So power is always measured in watts, or joules per second. The wattage or amount of electric power can be used to indicate how much energy our electrical device consumes. Power involves current, and the potential difference in an electric or electronic circuit can be described by the following equation. So P is equal to I times V, which is also equivalent to I squared R, or which is also equivalent to V squared R. So the letters are on this side. Now here are examples of some of our appliances together with their power. So don't forget, electrical energy is the ability to do work, and its unit is similar to the work or energy, which is joule. Now let us take a closer look on this example. A current of 10 amperes flows through an air conditioner connected to a 220 volt source. What is the power supplied to the air conditioner? So looking back at our formula, we could find this one. P is equal to I times V. I is current and V is the voltage or the potential difference. So from the problem, 10 amperes times 220 volt will give us a power of 2,200 watts. So the air conditioner produces 2,200 watts of power. Understand? Now let's move on. What do you see in the picture? I know most of you are familiar with this one. What is that? Very good. This is what we call electricity meter. An electricity meter is a device that measures the amount of electrical energy consumed by a house in kilowatt hours. So this is a device, I repeat, that measures the amount of electrical energy consumed by a house in kilowatt hours. So the electricity meters are used to provide accurate billing to consumers, or what we call the customers. To calculate energy consumed by a house, the units for energy, power, and time are greater due to the large amount of energy. So based on the relationship between electrical energy and power, work is equal to power times time. The energy consumed in a house is measured in kilowatt hours as the unit. So power is measured in kilowatts and time in hours. So the unit for electrical energy for the electricity meter is measured in kilowatt hours. So where did we get kilowatt hours? From the formula, work is equal to power times time. So the work, or the W, represents the electrical energy in kilowatt hours or units. And the P represents the power in kilowatts. And T represents the time in hours. So if you combine all together all those variables, we will be forming kilowatt hour, this one. Okay, so let us see an example. So in your book, you can see here an example how we could derive the electrical energy and then how is it calculated. Now, how much electrical energy in units is consumed by a 150 watt electric fan for 9 hours? So 150 watt electric fan for 9 hours. So how do we answer this one? Now let's first see the given. 150 watts electric fan for 9 hours. What is this? Does anyone know what 150 watt is? This is the power. Very good. What about 9 hours? So easy. So this is the time. So what are we looking for? We don't know the electrical energy. So how do we get electrical energy, or the W? So going back to our formula, W is equal to P times T, power times time. But first, take note that W is in kilowatt hour unit. So W must be in kilowatt hour. So let us first convert this watt unit into a kilowatt. So what should you do? This one. Okay. So 150 divided by 1000. And then you will get an answer there. And then you multiply now this one with the time. So finally, you would end up getting this answer. Did you get the same thing? Very good. So if you got the same thing, that means to say that you understood the lesson. So therefore, the electric fan consumes 1.35 kilowatt hour or 1.35 units of energy in a span of 9 hours. Okay. The uses of our electrical appliances. Okay, these are the things or some tips or guidelines in order for us to save energy and in using some of our electrical appliances safely. Okay, so you can see here. Okay, just like for example, the use of incandescent bulbs. And also how we can maximize the use of our electrical appliances, especially heating. Okay, and then how can we make the most of them in order for our work to be finished in a short period of time, like in the, and also this one, okay, in other appliances. Okay, so I hope you understood our lesson for today on how to calculate the electrical energy of our appliances, how to calculate our electrical consumption in kilowatt hour. Okay, I hope everything is given to you clearly. Do you have any question, girls? Okay, very good. Now let's do the activity time. I'd like you to open the PDF file and do the activity indicated about electrical energy. You have to print this worksheet and send this when you come back to school. Good luck! After our lesson, you click the link in MS Forms and answer the quiz. Answer the quiz today. Your point will be recorded. So thank you so much for listening today. I hope you had a good time. See you in the next period. Goodbye!